Hello everyone, this is Dr. Jude, PG and Research Department of Physics from St.Joseph's College of Arts and Science, Cuddalore. Today we are going to discuss about three models of nucleus: liquid drop model, nucleus shell model, and collective model. Collective model is the combination of both liquid drop model and nucleus shell model. First of all, we are going to see the drawbacks of liquid drop model, in which shell model has to be evolved, and liquid drop model does not explain about the magic numbers. Here you can see detail about the magic numbers in the shell model, and the specialization of magic numbers that is not explained, not enough explained by liquid drop model. And it also doesn't explain about the excited states of the nucleus, and it does not able to calculate the nucleus spin for certain nuclei, not for all the nuclei. For certain nuclei, liquid drop model has the lack to explain the justification for the nucleus spin. The nucleus shell model is a theoretical model, and it is used to describe the atomic nucleus, and especially in the terms of energy levels. And nucleus shell model is a model of atomic nucleus, and it is the based on the Pauli's exclusion principle to explain the nuclear structure. The fundamental, as we all know, Pauli's exclusion principle, that is the fundamental of the to give explanation about this shell model, which also explains the nuclear structure in terms of energy levels. In order to study the complete nuclear structure, various nuclear shell models were proposed. One of the models is a shell model. You can see the schematic representation of the shell model, where it is nucleus, and the first shell contains 2 electrons, and obviously second shell 8 electrons, that is 2n square formula, and third shell has 18 electrons in the atom. The shell model is partly analogous to, it is similar to atomic shell model, which also describes about the arrangement of electrons in an atom. So when the electrons are filled in an orbit, so it is completely filled, and how it is able to fill the orbit is explained by the shell model. And it's very important, it also discusses about the stability of the nucleus. It's highly important. And the nucleons move randomly in a nucleus and collide into each other frequently in a liquid drop model. As a liquid drop model suggests, the nucleons has a collision inside the nucleus. Nucleons means protons and neutrons, and it is explained in the liquid drop model. The shell model suggests that each nucleon and nucleus moves in well-defined orbit, and it is next level in explaining the movement of nucleons inside a nucleus. And shell model suggests that it revolves the orbit in a well-defined orbit, and there is hardly makes any collision between them, since it is called as independent model. As we already discussed, the nucleons obeys Pauli's exclusion principle. No 2 electrons may have same state, occupy the same state at the same time. So it is not possible for electrons to have the same quantum number. The neutrons and protons are treated separately, and their states are considered. They have a separate orbit, fixed orbit, and it is explained in the shell model. Each have its own array of available quantized distances. The next point is, in this model, each nucleon is assumed to exist in a shell is just like an atomic model. As we discussed the fundamentals of the atomic model, the nucleon also have their own state, and it revolves around that fixed state. The nucleus shell associated with these certain magic numbers, and these magic numbers is exclusive significance in this shell model, because the in nuclear physics, a magic number is a number of nucleons, that is either protons or neutrons, that is completely filled in that orbit of the atomic nucleus. As a result, what happens is, if the protons or neutrons have the certain number termed as magic numbers, they show a greater stability in the nuclei. It is a very important term in shell model. or much more stable than any other nuclei if the protons and neutrons have a certain numbers, and the certain numbers are called as magic numbers. When a nucleus has an even number of protons and neutrons, such a nucleus is more stable than odd numbers. If the number of protons or neutrons is an even number, for example 2, 4, 6, 8, such that it shows greater stability than 3, 6, 9 odd numbers. So the nucleus having a even number have greater stability, shows the greater stability than the odd number of nucleons. And you can see over there the magic numbers 2, 8, 20, 28, 50, 82 and 126. If these sequence of magic numbers has the number of protons or neutrons for a compound, it shows a greater stability. So there is a pattern, and this particular numbers are termed as magic. You can see over here helium, oxygen, calcium and lead. So they have doubly magic numbers, so they can termed as double magic numbers. You can see 2He4, O8, O16, calcium as 20 and lead as 126. So I have doubled their numbers in their atomic numbers. These contains isotopes. There are isotopes of these magic numbers of both protons and neutrons, and they are termed as double magic numbers. Double magic numbers can occur for isotopes that are heavier because of the repulsion of forces between the protons. Since it shows the forces or repulsion as a Coulombian repulsion existing between a proton and a proton, it shows greater repulsive force, and they are heavier when comparing to other, and it is called as isotopes. And you can see the important parameter called as electric quadrupole moment, which explains the charge distribution of a nucleus, either it is symmetric or non-symmetric. If the charge distribution is not evenly distributed, so there is a presence of electric quadrupole moment. The deviation from the spherical symmetric is called as electric quadrupole moment, and you can see any departure of nuclear charge distribution from spherical symmetry, it should be in the spherical distribution. It should have a spherical shape. The charge distribution should be spherical in shape, where Q is equal to 0. You can see the diagram over there. If the semi-major axis, semi-minor axis both are equal, so it has a spherical in shape. So we can say that the electric quadrupole moment has no electric quadrupole moment is present there. So you can see the expression of which explains electric quadrupole moment mathematically. E is a charge, and average nuclear, rho is average nuclear charge density, and d tau is the volume element. And second, if the charge distribution is expanded in horizontally, or you can say in semi-major axis, so we can say that the quadrupole moment is negative, and the structure is called as oblate. As we know that the structure is termed as oblate, and the electric quadrupole moment has a negative value. And if it is as the positive value, if the B is higher than the A, the charge distribution is in the shape like this, and you called it as a prolate. The structure is called as prolate, and these two are important in electric quadrupole moment, which this particular shell model explains in detail about this electric quadrupole moment of a nucleus. And you can see the graph, that is binding energy graph, whereas in x-axis we can say the mass number is taken as x-axis, and in y-axis it is binding energy of per nucleon in megaelectron volt. And you can see there is a maximum hits at Fe ion, and then if the mass number keeps on increasing, there is a decrease in the binding energy, which shows it has a greater stability. The greater stability occurs almost at ion Fe, and you can see there is similarly related to the magic numbers. As we discuss about this magic numbers, these magic numbers as it traces over there, which shows the maximum stability, and this binding energy gives the details about this particular magic number, which shows greater stability, and there is a correlation between them. And coming to the advantage of shell model over liquid drop model, it explains magic numbers. It's a very important term which explains magic numbers. It reveals certain numbers termed as magic numbers have number of protons and neutrons, which is similar to that magic numbers, and this sequence of numbers shows the greatest stability when comparing to other nuclei, and it explains the magnetic moment of some nuclei. It successfully explains the ground state spin. It is also an important term. The shell model explains the ground state spin, and you can know that 1h1 of neutron can be explained on the basis of shell model. And finally, the greatest stability and high binding energy. From the graph, we know that the higher binding energy and greatest stability can explain on the basis of shell model. And we know that there is certain limitations of shell model. It fails to explain the stability of 4 stable nuclei, 2He4, lithium and nitrogen. On the basis of the shell model, there is a conspiracy to explain about the stability of these 4 stable nuclei. It does not predict the correct values of nuclear spin of certain nuclei, not for all the nuclei, but for certain nuclei the nuclear spin cannot be explained on the basis of shell model. And finally, the quadrupole moment calculated using this model is not good agreement. There is some deviation or a kind of manipulation occurs in terms of quadrupole moment while calculating the quadrupole moment on the basis of shell model. Thank you.